Hi everyone, in this video we're going to look at a set of data and how to calculate the Pearson correlation coefficient by hand for this data. And this is quite a task. This really is more than anything so we understand what this number means and where it comes from. And for the most part, especially with a large set of data, we're going to let our calculator do the work for us. So here you see a set of data. And the points are plotted on this graph. And you can see that a nice positive trend in our data. It's not perfect, but we would expect a pretty good positive correlation with this data. As the x gets bigger, the y's are getting bigger. We get this guy up here that's really throwing a wrench in things. And if we wanted to draw a line at best fit, we could probably see it'd be going right about through there. So correlation is nothing more than a measure of how good that fit is of that line of best fit. So we'll move this guy over here. We'll make a little room for our calculation here. And this sort of looks like a standard deviation formula. But if you notice down the bottom, it's got two standard deviations in the formula itself. So it's going to require some organization to compute this. So we're going to find the difference from the mean of each x value times the difference from the mean of each y value. And we're going to add all of those up for all of our data points. We're going to divide by n minus 1, and we're going to divide by the standard deviation of the x's, and we're going to divide by the standard deviation of the y's. And really, this is just giving us a sense of how much the change in x is actually causing a change in the y. As we go over, is there a nice, reasonable pattern going across? So the first thing that we're going to do, we need to know these means for the x and the y. So I'm going to make a column here that's the difference of each x value from the mean, just like we were from standard deviation. And I make a column for each y value minus the mean. And then we're going to multiply those together. So each x value minus the mean times each y value minus the mean. And we're getting very involved here. So our mean value for our x's, so let's just calculate that down here real quick. Each x value, 0, 2, 4, 6. Sum is 12 divided by 4 gives us 3. And the mean of our y values, y bar, 3, 4, 7, 6 added together give us 20 divided by 4 gives us 5. So there's our average of our x's and average of our y's. Now we'll come over here and we'll do each x value minus the mean of the x's. 0 minus 3 is negative 3. 0 minus 2 is negative 2. 4 minus 3 is 1. And 6 minus 3 is 3. Nope, there's a mistake there. There it is. 3 minus 2 is negative 1. And I was making sure that this totaled 0, just like it did when we calculated standard deviation. All right, so now over here with the y values, let's scooch this over a little bit because we're taking up a lot of space. I need a little more space over there. So each y value minus the mean, which is 5 for the y's, so 3 minus 5 is negative 2. 4 minus 5, negative 1. 7 minus 5 is 2, and 6 minus 5 is 1. Again, check. That total should be 0. All right, so now we're going to multiply these together because that's what this says. We're going to multiply each of these together and then add to get the total. That'll be our numerator. So negative 3 times negative 2 is positive 6. These values can be negative over here. Negative 1 times negative 1 is 1. 1 times 2 is 2. 3 times 1 is 3. And if we add these guys up now, our total of this column is 12. And that's what our numerator says to do. Difference from the x's times the difference from the y's for each point totaled up. So let's slide this over just a bit, and we'll add in a 12 on top there. So 12 divided by, so on the bottom, we've got 3 things. We've got n minus 1, so we know that there's 4 data points. So 4 minus 1 is 3. But what is the standard deviation of the x's and the y's? So I'm going to next to here. So just like before, we need for the standard deviation of the x's, the difference from the mean squared. And then we'll have to do the same thing for the y's, the difference from the mean squared. And then we're going to divide by one fewer than what we have. So come all the way back here to this column right here. I'm going to connect these edges. This guy is going to come over here squared, and the y's are going to come over here squared. So 3 squared, 1 squared, 1 squared, and 3 squared. Total those guys up real quick, and we get 20. The y squared, so 4 and 1 and 1 and 4. So the difference from the mean squared for the y values, total these guys up, and we get 10. I'm going to do my calculation right over here. So the standard deviation of our x's is the square root of the deviation squared, which is 20, over 4 minus 1. And minus 1 is 3. And the standard deviation of our y's is the square root of the deviation squared for the y values over 4 minus 1, which is also 3. And if you need to review that, look back at the video we just had a little bit ago about calculating standard deviation. So up here in our calculation, standard deviation of our x's is the square root of 20 over 3, whatever that is. And then the standard deviation of our y's is the square root of 10 over 3. And this clunky looking calculation, we're going to get our calculator out and we're going to perform that. And what we will get is our correlation value. And flop this guy, scooch it over a little bit so you can see it. So we want to do 12 divided by, I have a whole bunch of stuff in our denominators, so I'm going to put 3 in parentheses times these square roots won't need parentheses, square root of 20 over 3, and the square root of 10 over 3. And then parentheses, and there is our value. And quick check for ourselves, that value has to be less than 1 and bigger than -1, and it certainly is. So it's about 0.848. Now we've seen this R value before this year, we just didn't look at how to calculate it. And the way to get this off our calculator pretty quickly is we can hit the stat menu and get into our stat editor, put all our values. So here's our order pairs, 0, 3, 2, 4, 4, 7, and 6, 6. And real quick, once you've got them in there, do a quick check and make sure in your mode that your stat diagnostics is on. The default that you start your calculator with is off. You only have to change that one time. And then we can go stat calculate. We can get it in the 2 variable stats column, but I think it's easier to get it out of the linear regression, which we did earlier this year. And L1 and L2 for the X list and Y list. We'll leave this blank, we'll leave that blank because we just want the R value, and we hold our breath and cross our fingers. And there's our value. Probably should have rounded that to 0.849 off of our calculation. Like we said again, this is an indication there's a positive linear trend to this as the X is bigger, the Y's are getting bigger, and that's not the best picture, but we generally see this trend going off to the right.